Okay, so projectile motion is a motion in two dimensions. So if you've got a cannonball in a cannon like this, and let's say that cannon is directed at an angle with respect to the horizontal, and that angle is theta, right? So if you shoot the cannonball, what it's going to do is it's going to follow a trajectory something like this. Okay, so this motion, because it's in two dimensions, if you say x is in the x direction towards the right and y is this direction, it's a two-dimensional motion, and this motion is called projectile motion. Another example of this would be if you have a cliff like this and it's above the ground, above the ground, it's some height, let's say capital H, and now you kick a ball from here at an angle with theta like this. So what it's going to do is it's going to fly like this and come down like this, right? So this is another motion of another example of projectile motion. Now what we do in order to analyze this projectile motion is we break this two-dimensional motion into two one-dimensional motions, one in the x direction or horizontal direction, and the second one in the y direction. So we can always think like this two-dimensional projectile motion, it's basically a combination of two independent motions, in one in x and then one in y. So next we should note down that throughout the journey of this particle, after it launches and till it hits the ground again, it is being acted in the y direction by the gravity. So if I ask you what is the acceleration in the y direction throughout the trajectory, is minus g, and acceleration in the x direction is 0. Okay, so this is really important to know the accelerations in x and y. Now after this, it is a good step to write down the initial velocity, let's say, which is v0, angled at some theta with respect to x-axis, and to write down this into its components, and we're going to call those components v0x and then v0y. v0y is the y component of v0, and v0x is the x component of v0. So see, again, like we're again following the aim that we had, and then the way we understood projectile motion is one dimension in x direction and one dimension, one independent motion in y direction. So if those two motions are independent, might as well just divide this velocity that's at some angle theta with respect to x into its components. So in x direction, if you do that, you get vx cosine theta, and that is the red velocity right here, and in the y direction you get v0 sine of theta. So this is same as this in y plus this in x, and independently and all happening at the same time. Now it's a good idea to revise the equations of kinematics. The equations of kinematics say that final velocity is initial velocity plus acceleration times time. Okay, delta x is initial velocity times time plus half acceleration time squared. Final velocity squared is initial velocity squared plus 2 times acceleration times delta x. Okay, now these equations, they can be written down in terms of x dimension and in y dimension. What do I mean by that? What I mean by that is, two-dimensional motion like this, we now say that it's basically a combination of two independent motions, where in the x direction you've got v0 cosine theta, and in the y direction you've got the initial velocity to be v0 sine theta. Now using those two diagrams, which I have copied right here, you can write down the equations of motion. So first one is Vx equals V0x Ax cosine theta, where V0x is the initial velocity in the x direction and Ax is acceleration in the x direction. Similarly, delta x is V0 xt plus half Axt square. Vx square is V0 x square plus 2Ax delta x, and their counterparts are Vy equals V0y plus Ayt, and delta y equals V0yt plus half Ayt squared, and Vy squared equals to v0 squared plus 2ay delta y. So I have written down these 6 equations, which are basically these 3 equations, but one in x and then one in y. Now we note down this information ay is minus g and ax is 0. So if I use those two, ax equals to 0 and ay equals to minus g, I can write down these 6 equations like this. This goes to 0, so you just don't have that term here. This goes to 0 because ax is 0, and this goes to 0. So in the x direction, the equations are really simple. In the y direction, they are not as simple because in y direction acceleration is non-zero, it's minus g. So you just replace ay by minus g everywhere. So you get these equations.